In January 1944, weapons testers at Aberdeen Proving Ground in Maryland pressed the trigger on a prototype machine gun. The weapon fired exactly one round, then jammed. They cleared the malfunction. Tried again. Same result. One shot. Jam. The spent cartridge case refused to leave the chamber. Aberdeen Proving Ground was the United States Army's oldest active proving ground. It had been established in October 1917, 6 months after America entered the First World War. For over 2 decades, every significant American weapon had passed through its testing ranges. Thousands of rifles, hundreds of artillery pieces, countless experimental designs. The testers there had seen weapons succeed and fail in every imaginable way. What they witnessed that January morning was a failure unlike any they had seen before. The weapon sitting on the test bench was called the T-24. It was supposed to be America's answer to the most feared machine gun of World War II, the German MG42. American engineers had captured the German weapon, studied it, measured every component down to fractions of a millimeter, and built what they believed was an exact copy. They were wrong. What they had actually built was a monument to one of the most basic engineering failures of the entire war. A failure so simple, so obvious in hindsight, that it would delay American machine gun development by more than a decade. They had forgotten to account for a single measurement. 6.35 millimeters, about 1/4 of an inch, the length difference between the German cartridge and the American one. That 1/4 inch would cost years, it would cost lives, and it would prove that copying a weapon is not the same as understanding it. The story of the T-24 begins not in an American laboratory but on the battlefields of North Africa in 1942. That was where American soldiers first encountered a sound that would haunt them for the rest of the war. It was the sound of the future, a sound that represented what machine guns could become, a sound that American soldiers would not be able to match with their own weapons for another 15 years. The MG42 did not sound like other machine guns. The Browning M1919, which American troops carried, fired at roughly 400 to 600 rounds per minute. You could hear the individual shots, a rhythm, a pattern. The MG42 fired at 1,200 to 1,500 rounds per minute. The shots came so quickly that the human ear could not distinguish them as separate sounds. Instead, it produced a continuous tearing noise. American soldiers called it Hitler's Buzzsaw. The British called it the Spandau. German troops had their own names: Bonesaw, Hitler's Zipper, the electric MG. Whatever you called it, you did not forget the sound once you heard it, and you especially did not forget it if you were on the receiving end. The MG42 first saw combat in May 1942 with the German Afrika Korps during the Battle of Gazala. This battle, fought from May 26 to June 21, saw German forces under Field Marshal Erwin Rommel break through British defensive lines and capture the fortress of Tobruk. The MG42 proved itself in the intense fighting, demonstrating its reliability in the harsh desert conditions where sand and dust could jam lesser weapons. By mid-1942, the MG42 had been introduced on all fronts where German forces fought. Production that year reached nearly 18,000 units. The following year, production would exceed 116,000. By the time American forces landed in North Africa in November 1942 as part of Operation Torch, the weapon had already earned its fearsome reputation among British and Commonwealth troops who had faced it in the desert for months. The casualties in North Africa were severe. American units that encountered entrenched German positions with MG42 support often took devastating losses before they could even identify where the fire was coming from. The weapon's rate of fire was so high that German gunners could traverse across an advancing line of infantry and hit multiple targets in a single burst. German machine gun doctrine stressed 5 basic points: surprise, fire and movement, coordination of firepower, conservation of ammunition, and alternate positions. In defense, the MG42 was usually employed with its tripod to act as a heavy machine gun. Multiple firing pits were dug at various places along the front line, one to cover the expected avenue of enemy advance, another on the flank to support neighboring squads, and a third called the Schweige MG, or ambush position, about 50 yards behind the main line. These tactics made the Germans masters at making one man appear to be a whole squad by moving rapidly from one concealed position to another. One American officer during the early stages of the Normandy campaign later used exactly those words to describe German machine gun tactics. At Kasserine Pass in February 1943, American forces received a brutal introduction to German combined arms tactics. The MG42 played a central role in the German defensive positions that shattered the initial American advance. On February 14th, the 10th and 21st Panzer Divisions attacked American positions near Sidi Bouzid. Over the following days, the German assault destroyed nearly 100 American tanks and drove the defenders back more than 50 miles. Units reported being pinned down by machine gun fire so intense that movement became impossible. The distinctive tearing sound of the MG42 became associated with the heavy casualties American forces suffered during that battle. The campaign would eventually cost the Allies over 76,000 casualties before the Axis forces in Tunisia surrendered in May 1943. After-action reports from Tunisia consistently noted the German machine gun's superiority. Officers described a weapon unlike anything in the American arsenal, lighter than the Browning, faster, easier to manufacture, and absolutely lethal. The War Department's publication Tactical and Technical Trends documented a detailed assessment of the MG42 in late August 1943, following analysis by units including the 34th Infantry Division. The report highlighted the weapon's advantages over American designs: its stamped metal construction using riveting and spot welding for simplicity, its quick-change barrel system that allowed rapid replacement without tools, its cyclic rate of fire between 1,200 and 1,500 rounds per minute, far surpassing the BAR's 500 to 650, and the M1919's 400 to 600. By February 1943, U.S. Ordnance authorities had published the first formal report on the MG42 following testing of a captured gun. The quick barrel changing and belt feed systems were considered some of its best design features. What the testing team found astonished them. The MG42 was built using techniques that American weapons designers had dismissed as inferior. It was made primarily from stamped sheet metal, pressed steel parts that could be manufactured quickly and cheaply. The Browning M1919 required extensive machining. Skilled workers had to cut and shape metal for hours to produce a single receiver. The MG42's receiver could be stamped out in minutes. American engineers had initially mocked the MG42's construction when they first examined captured examples. They called it crude. They said it looked like it was made from tin cans. Then they tested it. The crude weapon outperformed everything in the American inventory. It was lighter than the Browning. It was faster. Its quick-change barrel system allowed gunners to swap overheated barrels in seconds without tools. A trained operator could complete the process in under 5 seconds. The barrel was recommended to be changed every 250 rounds to prevent overheating. The feed mechanism was reliable and efficient, and despite its stamped construction, it was remarkably durable. The MG42 operated reliably in a variety of climates, from the burning deserts of North Africa to the frozen steppes of the Soviet Union. In winter conditions on the Eastern Front, where temperatures dropped to -40 degrees, the cocking handle and the catch for the top cover were designed so that gunners could operate them wearing Arctic mittens or with a stick or rod. This was vital because contact by bare flesh on cold metal could cause instant frostbite. The German design required only 75 man-hours to produce compared to 150 for the earlier MG34. It used 27.5 kilograms of raw materials versus 49 kilograms for its predecessor. The cost was 250 Reichsmarks compared to 327. Revolutionary manufacturing efficiency that allowed Germany to produce over 400,000 units during the war. Production numbers tell the story. 17,915 units in 1942, 116,725 in 1943, 211,806 in 1944 and 61,877 in 1945 as Germany collapsed. The implications were clear. Germany had developed a weapon that was faster to build, lighter to carry, and more effective in combat than anything the United States was fielding. If America could copy this design, it would revolutionize infantry firepower. The War Department moved quickly. In 1943, they issued a contract to the Saginaw Steering Gear Division of General Motors. Saginaw received orders to construct 2 prototype copies of the MG42. The prototypes would be chambered not in the German 7.92 by 57mm Mauser cartridge, but in the American 30-06 Springfield, the standard American rifle round. This decision seemed logical at the time. American supply lines were already set up to deliver 30-06 ammunition to frontline troops. Every American rifleman carried a weapon chambered for that cartridge. Every American machine gun used it. Introducing a weapon that used German ammunition would create massive logistical problems. What nobody fully considered was that the MG42 had been designed specifically around the German cartridge. Every dimension, every tolerance, every clearance. The entire operating system was calibrated to work with a cartridge case that measured 57mm in length. The 30-06 cartridge case measured 63.35mm. 6.35mm longer, about 1/4 of an inch. In machine gun design, 1/4 of an inch is an eternity. Saginaw Steering Gear was not primarily a weapons manufacturer. Before the war, they made automotive parts, steering components for General Motors vehicles. They were experts in precision machining and mass production. But the war had transformed American industry. Automobile plants became tank factories. Refrigerator manufacturers started building aircraft components. Steering gear companies became weapons producers. Saginaw had been building Browning M1919 machine guns since receiving a contract on September 15, 1940. They delivered their first gun on March 27, 1941. They were the first automobile company to manufacture machine guns for the United States military. Their initial contract called for delivery of 280 guns at $667 per unit. By March 1942, they exceeded all expectations. By that deadline, they had delivered 28,728 guns and reduced the unit cost to $141.44. By the war's end, they had produced approximately 500,000 Browning machine guns, and the unit cost had dropped to just $54.72. They saved the government an estimated $240 million through their production efficiencies. Motion and time studies conducted at the plant were so effective that copies were incorporated into advanced courses at Harvard University. On June 30, 1943, Saginaw Steering Gear voluntarily offered the United States government nearly $6.7 million as a refund on their machine gun contract because their costs had come in so much lower than projected. They also manufactured over 517,000 M1 carbines at 2 facilities. In 1943, Saginaw was asked to take over M1 carbine production from a Grand Rapids, Michigan company that had failed to produce guns meeting durability standards. Saginaw immediately began production at the required quality level. Half of the 517,000 carbines were produced at their main Saginaw plant, the rest at the Grand Rapids facility they took over. They had earned the Army-Navy E Award with 2 stars for production excellence. They knew mass production better than almost anyone in America. What they did not fully understand was the intricate relationship between cartridge dimensions and operating system timing in a recoil-operated machine gun. The MG42 used a short recoil operating system with a roller-locked bolt. When the weapon fired, the barrel and bolt recoiled backward together for a short distance while locked together. Then 2 rollers in the bolt head cammed inward as they contacted angled surfaces in the receiver. This unlocked the bolt from the barrel extension. The barrel stopped its rearward movement. The bolt continued rearward under its own momentum. As the bolt traveled back, it extracted the spent cartridge case from the chamber and ejected it through the port in the side of the receiver. At the same time, it cocked the hammer and compressed the large coil return spring. When the bolt reached the end of its travel, the spring drove it forward again. This entire cycle happened more than 20 times per second at the MG42's standard rate of fire. The timing was critical. Every component had to be in exactly the right position at exactly the right moment. The German engineers who designed the MG42 had calibrated every dimension to work with a 57mm cartridge case. The bolt travel distance, the ejection port position and length, the feed system geometry, the timing of the roller unlocking, all of it was matched to that specific cartridge. Saginaw received the contract and began work in the summer of 1943. They had access to several captured MG42s. They carefully measured the components and began manufacturing American copies. They changed the barrel to accept .30-06 ammunition. They modified some components to use American standard measurements rather than metric. They substituted American steel alloys for German ones. They also added a significantly heavier bolt. The original MG42 bolt weighed approximately 505 grams, about 17.8 ounces. The T24 bolt weighed 1,332 grams, about 47 ounces, nearly 3 times heavier. This was done deliberately. The heavier bolt would cycle more slowly, absorbing more of the recoil energy before unlocking. This would reduce the cyclic rate from 1,200 or more rounds per minute to something more in line with American doctrine. They also modified the return spring to work with the heavier bolt. What they did not do was extend the receiver to accommodate the longer American cartridge. The records do not tell us who made this decision. We do not know which engineer approved the dimensions. We do not know if anyone raised concerns. Multiple factors may have contributed. Time pressure, competing priorities, a failure to recognize that the cartridge length difference mattered to more than just the chamber dimensions. What we know is that the 2 prototype T24 machine guns that arrived at Aberdeen Proving Ground in January 1944 were fundamentally flawed. They had been built to German receiver dimensions but were expected to fire ammunition that was 6.35mm longer than what those dimensions allowed. The testing began in January 1944. The testers set up the first prototype on the range. They loaded a belt of .30-06 ammunition. They aimed at the target berm. They pressed the trigger. One shot. The weapon fired. Then it stopped. The bolt had cycled. It had extracted the spent case. But the case had not ejected. It was jammed in the ejection port. Caught between the bolt and the receiver wall, they cleared the jam. Inserted a new belt. Tried again. Same result. The problem was immediately obvious to anyone who understood the mechanics. The ejection port, which had been designed for a 57mm case, was not long enough for a 63mm case. The spent cartridge was hitting the rear edge of the ejection port before it could tumble clear of the weapon. The returning bolt then slammed into the stuck case, jamming the weapon completely. The testers attempted to enlarge the ejection port on the prototype. This helped slightly with ejection but created new problems. The enlarged port weakened the receiver structure. It also affected the timing of the roller unlocking mechanism. The fundamental issue was that the receiver had been manufactured to German dimensions, and there was only so much larger the ejection port could be made without compromising the structural integrity of the stamped receiver. The testers tried the second prototype. It worked slightly better. It could sometimes fire several rounds before jamming, but the malfunctions were constant: failure to eject, failure to feed. The bolt would override the next round instead of stripping it cleanly from the belt. The average cyclic rate was only 614 rounds per minute when the weapon functioned at all, less than half the original MG42's rate, and with malfunction rates that made it useless for combat. During January and February 1944, the testing team fired a total of approximately 1,500 rounds through the 2 prototypes. They recorded roughly 50 malfunctions, about 1 jam every 30 rounds. For comparison, a properly functioning machine gun should be able to fire tens of thousands of rounds with minimal malfunctions. The Browning M1919, despite being older and heavier, routinely passed tests requiring extended firing with only a handful of stoppages. The T-24 was not just disappointing, it was catastrophically unreliable. The testers tried additional modifications. They swapped bolts between the two prototypes. They adjusted the timing of the feed mechanism. They experimented with different buffer configurations. They substituted various parts in an effort to place the weapon in a position to continue the test. All efforts failed. Nothing worked. The fundamental problem was dimensional. The receiver was too short for the cartridge. No amount of adjustment could fix that without essentially redesigning the entire weapon. In February 1944, Major C. Balison of the Office of the Chief of Ordnance authorized the termination of the trials when it became evident the weapon required further development. The official report, issued in March 1944, concluded that the T-24 machine gun prototype's functioning was unsatisfactory. It recommended that further development was required before the weapon could be subjected to standard light machine gun testing protocols. The realization that the .30-06 Springfield cartridge was simply too long for the prototype gun's mechanism to easily and reliably work with resulted in the discarding of the project. Saginaw steering gear did not get the opportunity to correct the flaws before World War II ended. Here is what makes this failure so remarkable. The problem was not obscure. It was not some subtle metallurgical issue or complex timing problem that only a specialist could identify. It was a matter of basic measurement. The American cartridge case was longer than the German cartridge case. The American copy needed to be longer than the German original to accommodate that difference. This was not advanced engineering, this was arithmetic. The exact measurements were readily available. The 7.9 2x57 Mauser cartridge case was 57 mm long. The .30-06 Springfield case was 63.35 mm long. Both measurements had been standardized for decades. The difference was 6.35 mm, 1/4 of an inch. Anyone with a ruler could measure it. And yet the T-24 was built without accounting for this difference. The failure of the T-24 had consequences that extended far beyond a single cancelled project. American infantry in World War II continued to rely on the Browning M1919A4 as their standard medium machine gun. It was a good weapon in many respects. Reliable, accurate, proven in combat since World War I. John Browning had designed the original water-cooled M1917 in 1917, and the air-cooled M1919 was developed from it shortly after the war. Variations had served in every American conflict since. But it was heavy. The weapon itself weighed 31 pounds. The tripod added another 14 pounds. The complete system with mount, traversing mechanism and accessories could weigh over 40 pounds. A complete gun crew with ammunition could be carrying more than 80 pounds of equipment. Moving that weight in combat was exhausting. The Browning also required a tripod for effective sustained fire. The MG42 could be fired effectively from a bipod at 1,200 rounds per minute. The Browning on a bipod was difficult to control even at its slower rate. It required extensive machining to manufacture. Where the MG42 used stamped parts that could be produced quickly, the Browning needed skilled workers to cut and fit each receiver. The manufacturing process was time-consuming and expensive, and it fired at half the rate of the MG42. 400 to 600 rounds per minute compared to 1,200 or more. In practical terms, this meant German machine gun crews could put twice as much lead in the air as their American counterparts in the same amount of time. The standard German infantry company of 150 men in 1944 contained 15 MG42s, requiring only 30 to 50 men to crew them all. By contrast, only 2 light machine guns were assigned to each American infantry company. The doctrinal difference was stark. German forces used infantry to support machine guns. American forces used machine guns to support infantry. The German approach delivered overwhelming firepower at the point of contact. The Browning automatic rifle, the BAR, served as America's squad automatic weapon. It was even less comparable to the MG42. The BAR used 20-round box magazines rather than belt feed. A German MG42 crew could fire hundreds of rounds in sustained bursts. A BAR gunner had to reload every 20 shots. The rate of fire was similar to the Browning M1919, about 500 to 650 rounds per minute. The BAR weighed about 20 pounds for a weapon with significantly less sustained firepower than the German alternative. The disparity in firepower contributed to casualties throughout the European and Mediterranean theaters wherever American forces faced entrenched German positions. The failure also delayed American development of a true general-purpose machine gun. The MG42 had pioneered this concept, a single weapon that could serve as both a light machine gun carried by infantry and a heavy machine gun mounted on a tripod for sustained fire. Before the MG42, armies used different weapons for these different roles. The Germans showed that one weapon could do both jobs. Mounted on a bipod and it became a light machine gun. Mounted on a tripod and it became a heavy machine gun. The same basic weapon, the same training, the same spare parts, the same ammunition. American doctrine did not fully embrace this concept until after the war. America did not field a comparable general-purpose machine gun until the M60 entered service in 1960, more than 15 years after the T-24 failure. The development path from the T-24's failure to the M60's adoption was long and expensive. The United States Army recognized after World War II that German machine guns had been superior to American designs. The T-24 had failed, but the lessons from that failure would inform future development. The next generation of American machine guns would borrow heavily from German concepts while avoiding the dimensional mistakes that had doomed the T-24. The T-44 came first in 1946. It was developed by Bridge Tool and Die Company, combining the FG-42 operating system with the MG-42 belt feed mechanism. The FG-42 was a German paratrooper rifle, the Fallschirmjägergewehr, designed for Luftwaffe. Airborne troops, after heavy casualties at Crete in 1941, demonstrated the need for a weapon paratroopers could jump with. The FG-42 used a gas-operated rotating bolt system rather than the roller-locked mechanism of the MG-42. The T-44 used a vertical feed system that ran the ammunition belt up the left side of the receiver. This was unusual and created complications. The weapon was also too light for sustained automatic fire. It worked poorly. The combination of different design philosophies created problems that the developers struggled to resolve. Then came the T-52 series in the early 1950s, when the new 7.62 by 51mm NATO cartridge was adopted. This new cartridge was developed from the T-65 experimental series, based on work that had begun at Frankfurt Arsenal in the 1940s, using the 300 Savage as a starting point. The goal was a cartridge that matched .30-06 performance in a shorter, lighter package. The eventual 7.62 NATO cartridge was 51mm long compared to the 30-06's 63mm, 12mm shorter. The T-52 switched to a horizontal feed system similar to the MG42. This improved reliability. Multiple variants followed as engineers worked through problems. The T-52, the T-52E1, the T-52E2, the T-52E3. Each version incorporated improvements learned from the previous iteration. Gas systems were refined, feed mechanisms were adjusted, barrel change procedures were simplified. Finally, the T-161 series in the mid-1950s, the T-161E3 was finalized by the Inland Division of General Motors, the same company that had produced M1 carbines during the war. In February 1957, it was type classified as the M60. The weapon entered active service with troops in 1960. This weapon was chambered for the new 7.62 by 51mm NATO cartridge. This was a shorter round than the 30-06, 51mm compared to 63mm. The shorter cartridge made design easier. The dimensional problems that had plagued the T-24 were avoided by changing the ammunition standard rather than forcing incompatible dimensions. Over a decade of development, millions of dollars, thousands of engineering hours, all to produce a weapon that incorporated lessons the Germans had already applied in 1942. The irony is that the information Americans needed was available throughout this period. Captured MG42s sat in testing facilities. German engineers who had worked on the design were available for questioning after the war. The specifications were documented. Countries around the world successfully adapted the MG42 to their needs during this same period. West Germany converted their remaining MG42s to fire 7.62 by 51mm NATO ammunition. They extended the receiver, they modified the bolt, they adjusted the timing. Rheinmetall had to reverse engineer the weapon because the original technical drawings had been captured by the Soviets at the end of the war and ended up in Czechoslovakia and Yugoslavia. But the German engineers understood how the weapon worked and why. When they rechambered the weapon for the shorter NATO cartridge, they adjusted all the related dimensions. They understood that changing the cartridge meant changing the receiver length, the bolt travel, the ejection port geometry, and the timing of the entire operating cycle. They also added a heavier bolt, increasing the weight from the original 505 grams to 950 grams, which reduced the cyclic rate from 1,200 or more rounds per minute to a more controllable 700 to 900. Production of the first post-war variant, designated the MG1, was launched in 1958 at the Rheinmetall factory. The MG1A1 added a chrome-lined barrel and sights properly calibrated for the new cartridge. The MG1A2 added the heavier bolt and friction ring buffer. Wartime MG42s still in service were converted to the standard NATO chambering and designated MG2. The definitive MG3 designation was introduced in 1968 with an improved feeding mechanism that included a belt-retaining pawl to hold the belt up to the gun when the top cover was lifted. It also featured an added anti-aircraft sight and a new ammunition box. The MG3 remains in service with the German military today. Production rights were purchased by Italy, Greece, Iran, Pakistan, Spain, and Turkey. Over 40 countries have acquired the weapon and its variants. Yugoslavia produced the M53 starting in 1953. Using original German factory machinery that they acquired as war reparations after the Soviet transfer of captured equipment. They retained the original German 7.92 by 57 cartridge. By keeping the original cartridge, they avoided the dimensional problems entirely. The M53 was built at the state-owned Zavody Crvena Zastava company as a nearly exact copy of the original weapon. The only major differences were a slower 950 rounds per minute cyclic rate achieved through a heavier bolt, and no anti-aircraft sight mount. The M53 worked reliably because it was dimensionally identical to the original German design. It served as the standard Yugoslav machine gun for decades. The last military use of M53s in Yugoslavia was in 1999. Some quantities were exported to Iraq in the 1980s and saw extensive action during both Gulf Wars. Italy produced the MG42/59 starting in 1959. Licensed from Rheinmetall and manufactured by Beretta, Whitehead Motorfides, and Franchi. Rechambered for NATO ammunition with an extremely heavy bolt of 1,200 grams for a reduced 800 rounds per minute cyclic rate. It has served mounted on Italian vehicles and helicopters. Austria developed the MG74 in 1974, based on the Italian design. Manufactured by Steyr-Mannlicher, with a 950-gram bolt for approximately 850 rounds per minute rate. Features include a lightweight plastic buttstock and improved sights. It remains the standard machine gun of the Austrian Bundesheer. All of these programs understood the basic principle that the American T-24 program had missed. If you change the cartridge, you must change the dimensions to match. There is a persistent myth that the T-24 failed because the 30-06 cartridge was too powerful for the MG42's operating system. This explanation appears in some accounts of the project. It is not accurate. The German 7.92 by 57 Mauser cartridge and the American 30-06 Springfield cartridge had very similar power levels. They generated comparable chamber pressures. They produced comparable muzzle velocities with comparable bullet weights. The German round actually used heavier bullets in some loadings. The issue was not power, it was geometry. Length, not strength. The cases were different lengths. That was the problem. This distinction matters because the power myth implies that the MG42 design was somehow inadequate for American ammunition. The reality is that properly engineered copies succeeded. West Germany, Italy, Austria, and others all converted MG42s to fire cartridges with similar power to the 30-06. Their conversions worked because they adjusted the dimensions. What the MG42 could not handle was being built to the wrong dimensions. The M60 entered service in 1960. It was not a perfect weapon. It had its own problems that would become apparent during its long service life. The bipod was attached to the barrel rather than the receiver. This meant that when the gunner changed a hot barrel during sustained fire, he also had to remove the bipod. The barrel needed to be changed after approximately 200 rounds of rapid fire to prevent overheating. In combat, fumbling with a detached bipod while trying to quickly swap a glowing hot barrel was awkward at best and dangerous at worst. The gas system was complex and prone to fouling. It required frequent cleaning to maintain reliability. In the humid jungles of Vietnam, where the M60 would see its heaviest combat use, keeping the gas system clean was a constant challenge. The receiver was prone to cracking after extensive use. Testing determined that the M60 receiver was good for approximately 100,000 rounds before failure, compared to about 2 million for the later M240. The stress of thousands of firing cycles eventually fatigued the metal. The trigger group had a tendency to fall out if not properly secured. An embarrassing defect for a military firearm that could leave a soldier without a functioning weapon at a critical moment. The feed tray could not be closed with the bolt forward, complicating loading procedures. But despite these problems, it worked. It fired reliably when properly maintained. It could be produced in quantity at reasonable cost. American infantry finally had a general-purpose machine gun that could serve both as a light weapon on a bipod and a heavy weapon on a tripod, just as the Germans had demonstrated 2 decades earlier. The M60 served through Vietnam, where it earned the nickname the Pig because of its weight and the difficulty of carrying it through jungle terrain. At 23 pounds unloaded, it was lighter than the old Browning, but still a burden for the soldier assigned to carry it. Soldiers noted its problems, but relied on its firepower. In the close-quarters fighting of Vietnam, the ability to put heavy fire on enemy positions was often the difference between survival and death. Later variants addressed some of the original defects. The M60E1 moved the bipod to the gas cylinder where it stayed with the weapon during barrel changes. The M60E3 was a lightened version designed for Special Operations Forces. The M60E4 incorporated numerous improvements learned from decades of service. Eventually, the M240 replaced the M60 in most American military roles starting in the 1980s and 90s. The M240 was based on the Belgian FN-MAG, itself a design heavily influenced by German World War II machine guns. The MAG used a gas-operated system similar to the BAR, combined with a feed system derived from the MG42. The cycle of international influence that began with German designs continued into the modern era. The 2 prototype T-24 machine guns that were tested at Aberdeen in 1944 were eventually scrapped. No examples are known to survive today. Only photographs and test reports remain. The photographs show weapons that look almost identical to the German MG42. The same general shape, the same stamped receiver, the same barrel configuration. American bipods and tripods attached instead of German ones. American rear sights replacing German ones. They look like they should work. They look professional, well made. The differences that mattered were invisible. Inside the receiver, where the bolt traveled. At the ejection port, where spent cases should have escaped but did not. In the timing of the entire mechanism, calibrated for a cartridge that was not the one being fired. Saginaw steering gear went back to building Browning machine guns and M1 carbines after the T-24 failure. They continued producing weapons at massive scale until the war ended. The company returned to automotive components after the war. Through mergers and reorganizations, they eventually became part of the modern automotive supply industry. The MG42 story did not end with the war. The weapon that American engineers could not successfully copy in 1944 is still in production today. More than 80 years after it first entered service, variants of the MG42 remain in military inventories around the world. The German MG3, the Italian MG42/59, the Austrian MG74, the Pakistani variant, the Turkish variant, Spanish, Greek, Iranian, and Sudanese versions. All are essentially the same weapon that American soldiers faced on the beaches of Normandy and in the hedgerows of France. The design was that good. It worked so well that decades of subsequent development have failed to significantly improve upon it. Modern materials have allowed weight reductions. Modern manufacturing has reduced costs. Improved metallurgy has extended barrel life. Better optics have increased accuracy. But the basic operating principle remains unchanged from what Werner Gruner designed in the late 1930s. Roller-locked, belt-fed, quick-change barrel, high rate of fire, general-purpose application. The German military still uses it. The Bundeswehr fields the MG3 alongside more modern weapons like the MG4 light machine gun and the MG5 general-purpose machine gun. They have tried to replace the MG3 several times. Development of the MG5 began partly because of difficulties keeping the aging MG3 fleet operational. But reliability concerns and production delays have slowed the replacement process. As of today, the MG3 continues to serve on German armoured vehicles and in other roles. The weapon has seen combat in conflicts the original designers could never have imagined. In the Balkans during the 1990s, in Afghanistan in the 2000s, in the Middle East in the 2010s. Yugoslav M53s were used by all sides during the breakup of Yugoslavia. Iraqi forces used exported M53s during both Gulf Wars. Wherever conflict has erupted in the past 80 years, some variant of Werner Gruner's design has likely been present. The designer was Werner Gruner, an engineer at Grossfuss Metal und Lackierwarenfabrik in Dobeln, Saxony. The company had previously manufactured stamped metal products like sheet metal lanterns and other household items. They had no prior weapons experience. They were invited to compete because their expertise in stamped metal manufacturing was exactly what the German military wanted for their next-generation machine gun. The development began in February 1937, when the German military issued a draft specification for a new weapon to replace the MG44. 3 companies were invited to compete. By April 1938, initial trials of the Grossfuss functional model were underway. The design demonstrated the manufacturing advantages the military was seeking. The Grossfuss design was selected for production development in February 1939, receiving the designation MG39. Approximately 1,500 pre-production MG39/41 guns were manufactured for combat trials in 1941. Feedback from frontline troops was incorporated into final modifications. The final model was officially accepted in early 1942 and designated the MG42. Production began immediately with contracts going to Grossfuss, Mauser Work, Gustloff Work, Steyr, and others. By May 1942, the new weapon was in combat with the Afrika Korps. Werner Gruner's genius lay not in revolutionary mechanisms but in manufacturing efficiency. Every element of the MG42 was designed to be produced quickly and cheaply while maintaining reliability. Stamped parts instead of machined ones. Simplified assembly. Reduced material requirements. The result was a weapon that Germany could produce in massive quantities, even as Allied bombing devastated German industry. American engineers had that design in their hands in 1943. They measured it, they photographed it. They documented it in meticulous detail. They could not make it work. The failure was not about capability. American industry could manufacture anything. During World War II, American factories produced over 300,000 aircraft, nearly 90,000 tanks, thousands of ships of every type. The industrial output was unprecedented in human history. The same factories that built the T-24 prototypes were simultaneously producing hundreds of thousands of successful weapons. But manufacturing capability does not automatically translate to engineering understanding. American factories could stamp out millions of identical parts. They could assemble complex machines at rates that astounded the world. They could meet production quotas that seemed impossible. But they could not always understand why foreign designs worked the way they did. The T-24 was built in facilities that had already proven they could produce excellent weapons. The Browning machine guns that rolled off Saginaw's assembly lines were reliable and effective. The M1 carbines were well made and functional. The workers were skilled, the machinery was excellent, the quality control was rigorous, None of that mattered because the fundamental dimensions were wrong. The men who worked on the T-24 did their best with what they knew. They were not incompetent. They were engineers working under wartime pressure with limited information and competing priorities. They had multiple projects demanding their attention. They had deadlines to meet. They had a war to win. But they made a mistake, a fundamental error that doomed their project before the first round was ever fired. Someone built a machine gun with the wrong dimensions. That is not a political problem. That is an engineering problem. And engineering problems have engineering solutions. The solution was known. Extend the receiver, lengthen the ejection port, adjust the bolt travel. Account for the longer cartridge in every dimension that mattered. Other countries did exactly this and succeeded. The West Germans did it. The Yugoslavs kept the original dimensions by keeping the original cartridge. The Italians did it. The Austrians did it. America did not. Not in 1944. Not with the T-24. The recovery took time, over a decade of development work. Multiple failed prototypes. The T-44, the T-52 series, the T-161 series. Each iteration moved closer to a functional weapon. The M60 eventually gave American forces a general-purpose machine gun. It was not perfect. It had problems that would frustrate soldiers for decades. But it worked. It provided the kind of sustained automatic firepower that American infantry had lacked during World War II. The M60's successors improved on its design. The M240, adopted in the 1980s, was more reliable and longer-lasting. The M249 provided a lighter option for squad use. American small arms development recovered from the T-24 failure and went on to produce some of the finest infantry weapons in the world. But the recovery took time, years of development, millions of dollars in research and testing, and during that time, American soldiers carried weapons that were inferior to what their enemies might field. The T-24 represents a specific kind of failure, not a failure of capability or resources or dedication, a failure of understanding. The engineers who built it had the measurements, they had the specifications, they had captured examples to study. They had everything they needed except comprehension of how all the pieces fit together. Understanding is what matters. Understanding how systems work. Understanding why dimensions were chosen. Understanding the relationships between components. The MG42 was not a collection of random parts that happened to work together. It was an integrated system designed by engineers who understood exactly what they were building and why. Every dimension served a purpose. Every tolerance was calculated. The cartridge length determined the receiver length, which determined the bolt travel, which determined the timing of every other component. Werner Gruner and his team at Grossfuss understood this. They designed every element of their weapon to work with a specific cartridge. When they chose the 57mm German round as their basis, they built everything else around that choice. The T-24 engineers did not understand this. They thought they could change the cartridge without changing everything else. They treated the weapon as a collection of parts rather than an integrated system. Without that understanding, all the capability in the world produces nothing but expensive failures. Consider what might have been different. If the T-24 had worked, American troops landing at Normandy in June 1944 might have carried weapons as formidable as those defending the beaches. The suppressive fire that pinned down soldiers at Omaha Beach might have been matched by American weapons of equal capability. The hedgerow fighting that followed might have gone differently. American squads advancing through the bocage country of Normandy might have had the firepower to suppress German positions more effectively. The winter fighting in the Ardennes during the Battle of the Bulge might have been less costly. American defenders might have had machine guns that could match the volume of fire from their German counterparts. We cannot know for certain. Counterfactual history is always speculative. The outcome of battles depends on countless factors beyond weapon. Specifications, leadership, training, terrain, logistics, morale, weather. But we can say with confidence that American soldiers went to war with machine guns that fired at half the rate of their German counterparts. We can say that the disparity in firepower was noticed and documented by officers in every theater where American and German forces met. And we can say that a successful T-24 might have changed that equation. All because of a quarter-inch, 6.35 millimeters. The difference between a 57mm German cartridge case and a 63mm American one. That measurement difference rippled through the entire weapon system. It affected the ejection port, it affected the bolt travel, it affected the feed mechanism timing, it affected everything. And because the T-24 engineers did not account for it, their weapon jammed after firing a single round. One shot, then failure. The sound of that failure echoed through more than a decade of American weapons development. It taught lessons that would be applied in the M60 program and beyond. It demonstrated that copying a weapon requires understanding, not just measurement. The MG42 continues to serve more than 80 years after its introduction. The T-24 exists only in photographs and testing reports. The contrast tells the story better than any analysis could. If you found this story compelling, please take a moment to like this video. It helps us share more stories from the Second World War. Subscribe to stay connected with these histories. Each one matters. Each one deserves to be remembered. Leave a comment below telling us where you are watching from. Our community spans the globe. Thank you for watching and thank you for keeping these stories alive.